You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Johanna Johnson, Sustainable Projects Lead for Logan Water at Logan City Council, and Mark Thomas, Design Manager with Downer Utilities and the Design Lead on the Logan Water Partnership. And today we're discussing achieving a circular economy through Australia's first biosolids gasification facility in Logan City. Welcome, guys.
Hi, Jo.
Hi, Jo.
Both of you have been involved in the Logan Water Partnership, but Jo, can you tell us a bit about how the Loganholme wastewater treatment plant project started?
Sure. So a couple of years ago, we did a project looking at different ways of dealing with our biosolids, which is a significant cost to Logan City Council. One of the opportunities that arose from this particular project was looking at gasification. And part of that was the ability to apply for federal funding from ARENA, which is the Australian Renewable Energy Agency. Of that, we were successful in getting a grant for this particular project for $6.2 million of the overall cost of the project. The reason biosolids management is such a big issue for the wastewater treatment plant is that we have things like rising costs in electricity, fuel, just our operating costs and haulage costs are significant. And of that, we're transporting our biosolids from Logan to the Darling Downs as part of a contract, which is about 300 kilometres away. So there's a significant cost, and gasification actually reduces our volume, or will reduce our volume by about 90%. Meaning that it would be a great outcome for Logan to go down the gasification path just on a cost-benefit association, but also our greenhouse gas emissions are reduced, and that's also partly to do with the fact that we have a really great product at the end of gasification called biochar, compared to the biosolids that are a significant amount of water, basically, so we're quite excited about the project.
So tell us about how biochar is developed.
So biochar is the end product of going through the gasification unit. So the gasifier is a hearth that's about ranges to about 650 degrees, and it basically sequesters the carbon, which biosolids have quite a significant amount of carbon in them, and that means that it's a stable carbon-rich form of charcoal that can be applied to land or be used as a fertilizer. It also has really high water holding capacity and has really high nutrients. So even though you're sequestering carbon, you still have the phosphorus and nitrogen available.
Mark, Jo's talked about a few of the positive outcomes that a wastewater treatment plant that use this technology would have. What are some of the things that you were excited by about this project?
Traditional ways of, dewatering and disposing of biosolids at treatment plants, traditionally in Australia, is through belt presses or centrifuges. And in this case, at Loganholme Wastewater Treatment Plant, which is the site we're looking at, it's belt presses, which gets to about 13 to 14% dry solids. I guess moving through and providing a biochar, which make it 90% dry solids. So there's a number of technologies that get there, but that being able to reduce the water content and actually coming up with a more user-friendly and kind of almost commercially, we think it will be commercially usable and potentially sellable to the markets. And so it gives us a lot more saving on operation and maintenance costs and potential get some income from that end product as well.
And so data measurement of the impact is obviously really important, and you're in a proof of performance trial at the moment. Can you tell us a bit about that?
We have actually started the trial. Unfortunately, we've been a little bit impacted with COVID-19, but we have commenced trials and we've got some initial results, which is showing some positive feedback. So the main things that we're trying to get out of the demonstration plant is obviously we want to check the reliability and it performs adequately. We're looking at air emissions as well, and I'll probably pass to Jo at some point in a minute to talk about some of those. We're looking at the biochar itself and the quality of that biochar, and making sure that we're destroying all of the pops. We also have to look at the heat balance. So, as Jo mentioned previously, we're looking for a heat energy neutral process. So, what we have to do as part of this demonstration plant is actually measure the heat produced and ensure that it's going to be enough or sufficient to power our dryers, which are going to be used in the main plant that we will need. And we're also looking at the costs and how much power and other chemicals and consumables that it needs to make sure it's going to be a viable system as if we roll it out into the main plant.
Jo, did you want to expand on some of those other measurements as well?
So in Queensland, we've got the new end of waste code for biosolids that came in about in 2019, and in that there's POPs are mentioned, and POPs are your chemicals that are toxic, non-biodegradable, and accumulate in the food chain. So they're not the nicest of things, and part of those are your PFASs, which is your perfluoroalkyl substances, and your nanoplastics and microplastics. Now, biosolids have PFAS, and they're known to have micro nanoplastics, and that can go into your food chain. So it was a big concern that our biosolids could have this sort of stuff. Now, the proof of performance is really looking at your recovering of your energy from waste and your destruction of your POPs, like micro nanoplastics and your PFAS, and then the compliance to our end of waste code. And so we are importing biosolids because our biosolids aren't dry enough, and as part of the trial, so we're getting biosolids that are around 90% dry and processing them in the gasification plant. So there was the trials at the moment are showing very interesting and positive results of destruction of your PFASs, and we're able to at the moment track where that goes in the system. So it's made volatile in the gasification half, which is at 650 degrees. And then these gases go to an oxidizer that's heated to 850 degrees for over 2 seconds retention time. And that's where it's destroyed. And we're getting really positive results in our air emissions analysis. And it's looking like a win-win scenario.
So, given the encouraging results, what's the next steps?
We've actually looked at the concept design of the permanent plant, and we're actually developing that design and going through the designs and costings of that, and coming up with, if you like, a capital cost, and based on the results that we get from the demonstration plant, obviously that will impact on whether the next phase goes ahead. But we're hopeful that it will be positive results, and obviously we're not just looking at capital costs, but the operating and maintenance costs, NPV calculations, so that we can work out if it's viable to go into that into the permanent plant. We're hoping to get results in the next couple of months, and after those results come through, we'll be in a position to put the project forward to get approval, and then hopefully start on the implementation and construction of the permanent plant, which would probably be towards the end of this year.
And do you think this project has implications for other organisations or partnerships, Jo?
Definitely. The reason why this project's so great, I think, is because we're retrofitting this gasification unit onto an 80s plant, wastewater treatment plant. So it's showing that it can be applicable for many of the other wastewater treatment plants that are going to have the same sort of issues. And also, I suppose it's the sustainable outcomes that we're getting from the treatment process. We're looking at having a biochar that is a usable product. It's and quite a lot less. So operationally, it's great, but also beneficial for the end product. But it also reduces our carbon footprint, and that's a massive benefit to this particular project, because I mean we're reducing our carbon footprint by 133,000 tonnes of carbon emissions because of the sludge mineralisation factor. So because we're sequestering the carbon in a biochar form. So all around those awesome outcomes, I suppose, show that this technology would be great for other wastewater treatment plants, but also can be applied to lots of other different areas.
There has been a lot of interest from other similar authorities, both in southeast Queensland, but actually around Australia as well. So I think this is a shared issue of how to dewater and, if you like, dispose of biosolids and hopefully reuse. So so I think there is a lot of interest out in the community.
What advice would you therefore have, Mark, for other partnerships or organisations looking to embark on a similar project?
Yeah, I think you really have to look at your current performance and the costs and performance of your plant to look at where you are and establish kind of, if you like, your baseline and really understand those things, so that when you're looking at how to get to a biochar, because it's a few different processes to get there. As Jo mentioned, you need to get to an 85 to 90% dry solids, so that does involve quite a bit of technology and process to get there. So you're looking at centrifuges, dryers to get it to that 85, 90%, even before you get to the gasification phase. So there is a bit of engineering and costs associated with that. So I think you really need to have a look at at your current costs and setup, and then look at the potential savings you can get. So you need a pretty good understanding of your costs and cost model with your operating costs as well as capital cost implications for trying to implement a project such as this.
And for any local councils, Jo, any advice?
There has been a lot of interest from local councils about this particular project, and they're all waiting to see what we're doing for the results. But I think the fact that it's such a sustainable and environmentally friendly and putting that value on the environment shows that it's a great project and worthwhile implementing in their wastewater treatment plants.
I've been speaking with Johanna Johnson, Sustainable Projects Lead for Logan Water at Logan City Council, and Mark Thomas, Design Manager with Downer Utilities and the Design Lead on the Logan Water Partnership. Thank you both for your time today.
Thanks, Jo.
Thank you.